Great. Hi, everybody. Thanks for having me. It's great to be back for another .NET Conf. I have so much to cover today, so let me just jump right into my presentation.
Hi, everyone. Thanks for joining me today. My name is Steve Smith, and you can find me online at ardallas.com or on Twitter and GitHub as @ardallas. If you're interested in learning more about ASP.NET Core, I encourage you to check out my ASP.NET Core Quick Start course at ASP.NET Core Quickstart.com. You can also listen to my weekly developer tips podcast at weeklydevtips.com. Finally, if you want to learn more about Razor Pages, check out my article in this month's MSDN magazine. Okay, let's get started introducing Razor Pages, which are a new feature in ASP.NET Core 2.0. Before we get started, I'd like to spend a few moments describing some myths that I've heard floating around about Razor Pages, as well as take a couple of moments to share some questions that I've been asked about this new feature online. Because Razor Pages sounds like a couple of past ASP.NET features, it's easy to make assumptions or become confused about just what the new ASP.NET Core 2.0 feature is all about. The first myth that I keep encountering is that Razor Pages aren't something real developers should concern themselves with, since they're just a poorly architected way to help students or .NET newbies ease into ASP.NET without all the rigor and proper architecture that software engineers value. The second myth is kind of an emotional reaction based on past trauma that some developers associate with working with ASP.NET web forms and their associated code behind pages. Unlike Razor Pages, ASP.NET Web Forms pages were typically difficult to test and often conflated UI, business, and data layer concerns. We'll see in a few moments how Razor Pages doesn't retread this path. And the third myth that I hear is that Razor Pages is a path to rotten spaghetti code that has no proper separation of concerns or abstraction layers. Now, that's not to say that you can't write lousy spaghetti code-ridden Razor Pages. You most certainly can. But you could do that with MVC views too. Just because you can doesn't mean that you must or that you should, as we'll soon see. Now, since it's tough for you to ask me questions live during this presentation, I thought I'd be proactive and solicit some questions ahead of time. Here are a few to get us going that I'll be sure to cover. One of the first questions that folks wanted to ask on Twitter was, what is the performance impact of Razor Pages? Is it going to be better to use Razor Pages than MVC or vice versa? Another question was about the specifics of certain handlers, and we'll talk a little bit about those in a few moments. Tahir wants to know whether it makes sense to use onPut and onDelete, especially since browser forms can't leverage these verbs. We'll talk more about that when we get to the handlers section. And then the third set of questions centers around filters. Filters are a great feature of ASP.NET Core, but they're most often applied to controllers and actions. How do they work with Razor Pages, and do Razor Pages get any of their own filters? We'll cover these questions as well. But first, let's spend a couple of minutes talking about the organization of your ASP.NET project. One of the myths I mentioned about Razor Pages is that they're only for new developers and small toy projects. However, one of the issues many developers face with larger, more complex ASP.NET applications is how to organize all the files required by the project in a way that makes sense and is optimized for efficient work. Forget about that big ASP.NET project you're working on right now. Just think about your computer for a moment. How many of you use this kind of folder structure as your primary organizational scheme for your Documents folder, OneDrive, Desktop, or Dropbox, wherever it is that you have a lot of your project-related folders? Take a look at the folder names that I have here on the screen. So what I want to know is, do you have a separate root-level folder for each different file type? I'm guessing none of you out there use this approach across the board, although you might have some folders, like for instance music, that are mostly organized at the top level by file type. In many cases, though, you're going to have projects that you're working on that involve multiple kinds of files. Trying to work on a presentation for work that involves a PowerPoint document along with a few different types of images, maybe an Excel sheet, a Word doc or two, would be a nightmare if you needed to constantly jump between half a dozen folders to do so that all just had a root-level organization based on their file type. So, why do you think it makes sense for us to use this type of organization for our web applications? Here's a typical MVC project structure, and you can see that it is simply organized based on the kinds of files that each folder holds. Thus, working on a particular aspect of the application most frequently involves touching files from many different folders. Imagine you're looking to add a feature to your MVC structured web project. Naturally, you start in the controllers folder. Is that where all the files are that you need to change? Or is it more like this, where you find yourself touching a controller, some database classes, at least one view model in its own folder, and then one or more views in their own folder? How much constant scrolling and spelunking through your Solution Explorer do you have to do just to work on a single feature of your application? It's like death by 1,000 paper cuts. Working with the default MVC folder structure starts to become painful as the application grows in size. Let's think about how we can clean this up. We can use Razor Pages to make it so that our project is better organized and reduces the friction involved in working with our ASP.NET Core web apps. Razor Pages are a new feature in ASP.NET Core 2.0. They're built into ASP.NET Core MVC, so you don't need to do anything special to add their capability. If you're on ASP.NET Core 2.0 and you've added MVC to your web application, you have access to Razor Pages. You can get started working with Razor Pages by simply adding a new ASP.NET Core web application in Visual Studio. The default web application template now uses Razor Pages by default. If you want to add the old Model View Controller folder structure, you need to explicitly opt into that by choosing the other template that specifies Model View Controller. When you create a new web app using Razor Pages, the default folder structure is very simple. The bulk of the app lives within the Pages folder. Of course, since .NET Core is cross-platform, you can create a new Razor Pages web app from the .NET command line interface as well. Whether you're using Windows, Mac, or Linux, the .NET CLI works the same across each of these platforms. When you do, you can see that this .NET New Razor template produces the same folder structure with a root Pages folder. Now here's the default home page of a new Razor Pages app. It looks pretty much like the view-based version with the addition of the app page directive at the top. Notice on the right that there's an index.cshtml file. That's the Razor page. Razor Pages use the same extension as your views from your MVC views. And associated with that is an index.cshtml.cs file. That's the code behind model class, and we'll talk about that in just a moment as well. The app page directive is new and is required by all Razor Pages. This is what tells ASP.NET Core to treat this class as a Razor page instead of as a view. Razor Pages can also specify a model using the @model directive that you're probably familiar with from views. Unlike views, however, Razor Pages will typically specify as their model a class that inherits from page model instead of a custom view model type. Let's look at this screenshot for just a moment. You can see that we have our simple index page at the top in index.cshtml, and on the bottom left, you can see the code behind page, which is index model, and this one inherits from page model. You can see that the page model type down in the bottom has a single method called onGet. We'll talk about that in just a minute. By convention, a Razor Pages model class is placed in a file named the same as the Razor Page file name, followed by CS. As you just saw, Visual Studio will group Razor Pages and their associated page model code behind files together when using this convention. The page model class in this case is sometimes referred to as a code behind file, but please don't let that term completely color your opinion of Razor Pages if you happen to associate it with painful web forms memories. You should avoid placing non-rendering logic in your Razor page directly. Instead, such logic belongs in the page model code behind class or inside of your business model or data access classes or services. Like the base controller class in MVC, there is a page model base class that provides some useful helper methods. So if you've been working with the MVC pattern for a while, it may be a little bit jarring to not have a controller involved anymore. Remember that in MVC, a controller is the entry point for your application. However, a controller is simply a way of organizing a bunch of action methods. Typically, action methods stand alone and don't depend on or call other action methods. Their grouping within controllers is simply a way that lets you find them easily and allows for them to share common dependencies, filters, and route templates. In Razor pages, controllers and actions have been replaced by handlers. Handlers live on Razor pages and use a naming convention of on plus the HTTP verb being used. For example, we just saw onGet. Another example would be onPost. If your handler is async, then it would use the naming convention onGetAsync or onPostAsync. The page, instead of the controller, becomes the unit of organization of multiple handlers. Obviously, this model works best for page-based workflows. One benefit of Razor pages is that they help achieve the goal that simple things should be simple to do. If you have a very simple page in your app that doesn't really do anything on the server and simply responds to a GET request, a Razor page is a great fit. You don't need to specify a page model if you don't need one, and the GET handler is automatic if you don't specify one yourself. Let's compare adding a simple static page to a web app using MVC or using Razor pages. All right, so let's assume that you want to create a privacy page for your web app. This is going to be a static page, and it should have a route that comes in from the root of your application to something like /privacy. The privacy page should use the built-in layout of the site, so you don't want to create it as a purely static HTML file and drop it in your www root folder. Instead, it makes sense to create this as a simple view in your MVC app. To add this functionality, you first need to add a controller. So you go to the controllers folder to create a new privacycontroller.cs file. This is useful because perhaps you have a basic convention already in place for routing that is going to make it so that if you go to /privacy, that's going to map to the privacy controller and then the index action method. Next, you need to add that action method to support this route. So you create a simple index method and you have it return a view. Now, of course, you need to create that view. So you need to go and create a views folder that corresponds with your controller because you're going to have to be able to have the index.cshtml view file live inside of this folder because that's the default convention that MVC uses to locate views. Finally, you're ready to add your privacy page, which you can now create inside that folder and put in your privacy policy for your site. Okay, so that's not too bad. For MVC, we just had to create a controller, create an action, create a views folder, and then create the view just to add this one simple page to our site. Now let's compare that to Razor pages and see if it's any simpler. So to create a simple static page in Razor pages, you add a privacy.cshtml file to the pages folder. That's it. You're done. Go home. So when it comes to simple pages, which, let's face it, most sites have a few of, Razor pages really shine. There's not a lot of work to be done. They avoid a lot of the ceremony and convention that MVC requires. And so in the simple case, Razor pages, I think, really shine. But that's not the only place that they're good. As we'll see in a few moments, they also can help you organize more complex workflows. Now, the question that some of you are probably wondering is, well, if MVC includes Razor pages, why can't I use both? Maybe I have some complex workflows that I'm happy using MVC for, but I also would like to be able to just add a privacy page and drop that into my pages folder and not have to go through all this rigmarole of creating a separate views folder and a separate view for something that has no logic and just displays content. Well, just like chocolate and peanut butter, you can certainly mix Razor pages with MVC in your ASP.NET Core applications. As long as your routes don't have a conflict, this can be a great approach that leverages the best of both worlds. So speaking of routes, let's talk a little bit about routing in Razor pages. In an MVC application, you typically start out with a home controller and an associated index action and view. You might have some route defaults that are used to ensure that a visitor who navigates to the root of your site is routed to the home controller and the index action method's associated view, index.cshtml. With Razor pages, you don't need a home controller as a placeholder for the root of your site. you simply put pages in the root of your pages folder, and they're routed accordingly. If you want to organize pages into folders, you can do so, and by default, their routes will follow suit. Razor Pages will route the slash or root level folder route to an index page in that folder, just like the default MVC route does. So as you can see in the slide shown here, if you have a route that goes to /about, by default that's going to go to a Razor page located in the root of the pages folder called about.cshtml. If someone is hitting your website and they're hitting just the root folder, that will route to /pages/index.cshtml, and you can also get to the same Razor page by going to /index. And of course, if you want to use folders, then you can place Razor Pages inside of subfolders and they will route accordingly. Within each Razor page, we talked about they have handlers for the verbs. If you don't need to perform any logic, the get handler will be handled for you automatically. So you don't have to specify an onGet handler if all you're going to do is return back that page. Now, as far as routing goes, in MVC, there's basically 3 different places that you would apply routes. You can apply routes globally when you're configuring MVC, and you can specify some default route conventions. You can also add routes at the controller level or action level using the route attribute, or you can also specify a route template when you specify the verb that a particular action is going to use. So when you've got an HTTP GET or an HTTP POST, you can optionally specify a route template to go with it. Razor Pages specify their route templates as part of the @page directive. So when you're looking at a page, in addition to just specifying @page, you can also specify its route template. In this case, you can see that we have a route template that is curly brackets with an ID that's been limited to being of integer type. And so this will correspond to routes such as /details/1, where the 1 now is going to be used as the ID parameter for this page's route. Note that when you use a route constraint like int, you will get a 404 if there is a non-matching route that is passed. So if I had instead /details/Steve, well, Steve being a string would not match the constrained ID:int route, and so that would not match this page. If it didn't match any page or other route, it would then result in a 404. When you're using Razor Pages, there are also some new tag helpers that you can use to work with them that are especially helpful for creating links to pages. For instance, instead of hard coding a route or a URL path, you can use the ASP_page tag helper to indicate the name of the page that you wish to link to, and the appropriate URL will be generated. This URL generation feature is actually part of routing that's built into ASP.NET Core MVC. Likewise, you can indicate a specific named handler that a form will submit to using the ASP-page-handler tag helper. In the example shown here, you can see that this is going to use the delete handler for this form. So whether the form was using a method of get or a method of post, it's going to look for a handler named delete to handle this particular form. Notice here also that you can add route variables, such as the route ID. In this case, you see I have ASP-route-ID, and I'm binding that on the form using Razor to the model's item.id type. In fact, you can use any ASP-route-whatever parameter name tag helper that you want, and that will automatically get added to the collection of route variables that is specified when it generates the URL. Now, this is not an Razor Page feature. The ASP-route tag helper exists as part of the forms tag helpers collection that you could use today in MVC. You may be familiar with it. When it builds the URL, if the route supports that placeholder, for instance, if I have an ID element inside of my route, inside my route template, it will incorporate that into the route template. So for instance, in the form example here, if I am expecting an ID as part of the route, then my URL is going to look something like /delete/ID, for instance. However, if the parameter that I'm specifying with the ASP-route helper is not something that is part of that route, then it will just get added as a query string. And so I might have something like, customers slash delete question mark ID equals, and then the ID. So the URL creation will either use query strings or part of the route, depending on the route template that's defined for that destination route that you're specifying. Now, instead of actions, as we've already mentioned, Razor pages use handlers. Handlers follow an event handler-like naming convention of onVerb or onVerb async. You'll most frequently see this used with onGet or onGet async and onPost or onPost async. In some cases, you'll want to have more than one handler for a particular verb on a particular page. In that case, you can use a named handler specifying the name as part of the method name. For example, onGetThankYou would be one option. Now the handler name is passed as a route parameter, so the ASP page handler tag helper is actually equivalent to the ASP route handler that I just talked about. And so if you don't have the handler as part of your route template, you'll see in the links that are generated when you use named handlers that they simply have a query string value of handler set to the value of whatever handler you're specifying. By default, named handlers are not baked into the route through any sort of built-in convention or magic. They will just use a query string-based handler syntax unless you specify them in your route template, which you can do in the @page directive as I already showed. Now, since Razor pages are built on the same fundamentals as ASP.NET Core MVC, you get some things like model binding and model validation out of the box, and these work pretty much as you would expect. There is a new feature in ASP.NET Core 2.0, and that is the bind property attribute, which lets you specify that a property of the page opts into model binding. Now, by default, this property will only be bound to non-GET requests, so for instance, posts. And this eliminates the need to include it in method parameters of associated handlers. So, for example, if you have a form and when the user posts that form, you want the corresponding handler for that to accept in the various elements that were on that form and use model binding. Well, if you use the bind property attribute, you can have those bound to properties on the page model instead of having to specify one or more parameters on your onPost method. Now, one of the reasons why this is handy is that this property is available on the GET request, even though it's not using model binding. And that means that your page can use it for rendering. So you can see in the slide here, I have an input ASP4 customer.name shown here. That is using a property on the page called customer, and I can use the ASP4 tag helper to create the input that corresponds to customer.name. And then when I do a post, it will bind that for me directly to that property in a strongly typed manner. So if I later on go and do a rename of customer.name and I call it customer.fullname, there won't be any magic strings in my HTML that correspond to the name of that form input. Everything will be matched to that model type on that property. Now again, this feature isn't limited to Razor pages. You can also use bind property on your controller properties and then access these properties from your MVC actions. However, they're not quite as useful on the controller side simply because you wouldn't use a controller property as part of your form binding like you can do with Razor pages. All right, so let's look at this in a quick example. You can see here that I have this customer property and I've marked it with the bind property attribute. And then in my onPost async handler, after I check that the model state is valid, I can go and work with that customer property directly, even though it wasn't passed in as an argument to the onPost async method. I have access to the property, and that property will be bound prior to this handler running because of that bind property attribute. Razor pages are a lot like views in many ways. Razor pages leverage the built-in MVC view feature set. Thus, you can define things like layouts and partial views and use them from your Razor pages. You can use the view imports and view start files to apply settings to all of your views globally or within a particular folder, and to run some code before each view. For instance, a common use of the viewStart.cshtml file is to specify the layout for each view. This will be applied to all views so that you won't have to set the layout on every view, and instead you can just set it on any view that might use a different layout or might not have a layout. Normally, these shared view files are stored in the root of the views folder or in the /views/shared folder. Razor Pages places them in the root of the pages folder by default, but will also search in the views shared folder as well. So if you're mixing Razor Pages and MVC views in your project, Razor Pages will look for these view files first inside of a pages folder, and then if it doesn't find them there, it will look inside of the /views/shared folder for a view that matches the name of whatever it is it's searching for. You can override this behavior by modifying the page view location formats collection shown here inside of startup.cs when you add MVC to your app. Another nice feature going for Razor Pages is that it bakes in protection against cross-site request forgery attacks, or CSRF. ASP.NET Core has support for issuing and verifying anti-request forgery tokens, but you need to be explicit about using these in ASP.NET Core MVC apps. With Razor Pages, this just happens automatically whenever you have a form on a Razor page and whenever you have a handler that is going to be accepting data from that form. This makes it so your Razor Pages are more secure by default because you don't have to take any action in order to get this protection. Now let's take a look at filters. You can add filters to your Razor Pages similarly to how you do with MVC controllers. In Razor Pages, you add filters globally or per page or handler. Most of the filters you're already familiar with from MVC still work the same with Razor Pages. These include resource, authorization, exception, and result filters. There's a new filter type introduced as well, which is the page filter, which uses the iPageFilter interface or the corresponding async version of that interface. Action filters are ignored by Razor Pages since Razor Pages use handlers instead of controller actions. You can apply Razor filters globally in startup.cs or on page model code behind classes. But note, you can't add filters to CSHTML pages. There's no convention for that at this time. So if you're using a page model as your code behind, you can use filters just like you do today inside your controllers. If you aren't using a page model, or if you want to try and use a filter inside just a Razor page.cshtml file, you can't use filters there at this time. Your choices are to apply them globally in startup.cs or to apply them on the page model class type. Here's an example of a page filter. This page filter implements attribute and iPageFilter. So it is an attribute and we can apply it to a page model class as an attribute, which we'll see in the next slide. And there are three methods that iPageFilter defines. These are onPageHandler selected, which you can see at the top there. And then there is an onPageHandler executing and onPageHandler executed. These correspond pretty much to what you would be familiar with if you already know about how action filters work today in MVC. So these handle basically two different cases, and most of the time I don't expect that when you write a filter that you're going to implement all three of these different filter types. The first one, onPageHandler selected, can be used to change how the selection of a handler is being done on your page. So in this example, it's simply going to take whatever method it was going to bind to and change it up and say, no, instead, I want you to use the handler method with the name edit. And we'll see in a second what that looks like. The other two methods here, executing and executed, run before, which is when executing runs, or after, which is when executed runs, your page handler executes. So this gives you an opportunity to hook into the pipeline in a way somewhat similar to middleware, but if you're familiar with filters, this is just like an action filter. And so you can perform some work in executing and then some different work perhaps in executed. A common thing to do inside of your executing page filter would be to check model validation so that you wouldn't need to do model validation logic inside every one of your form handlers that's supporting on-post operations. Now let's see how this filter would be applied to a particular page. Here I have a page model for a Razor page called filter test. And you can see at the very top, I have applied the handler changing page filter. Now, the handler changing page filter simply looks at whatever handler was being chosen and replaces it with one named edit. So in this case, you can see I have two different handlers, one for onGet and a named handler called onGetEdit. And no matter what, the onGet one is never going to be called at this point because my filter is going to always run and select the onGetEdit method instead. And so when you test out this page, you would see that you always get hello from onGetEdit and you'll never see hello from onGet. So just a very simple demo of how you can apply a page filter to your page model when using Razor Pages. Now, the other place that you can add filters in your Razor Pages is globally. So there are several different methods in the Razor Pages Options Conventions type that support configuring authorization rules. Authorization is typically done with filters in ASP.NET Core MVC. So you can apply authorization rules here from startup.cs to folders or pages using these conventions. So in the example shown here, you can see I am calling the options.conventions.authorizeFolder method here and specifying the admin folder. And similarly, the authorize folder is being called on the /accounts folder. Both of those will now require that the user be authenticated and logged in. However, if I want to sort of punch a hole in that rule and allow anonymous to a particular page within one of those folders or a whole subfolder of one of them if I wanted, I can use the conventions.allowAnonymous to page method to specify that the login page does not require that you be authenticated, since that would be silly since you'd have to be authenticated before you could log in. You can also use these conventions to configure filters. So you can go and say options.conventions configure filter and provide an instance of a filter. And this filter will run for every single page in your application. If you want to conditionally specify filters based on certain types of variables like the page's name or file path or route parameters or a number of other things that are available off of this model type, you can use the .configure filter overload that takes in a lambda expression, and that lambda expression is basically a factory that returns a filter. So you can return, one filter for one path or for one set of conditions, and a different filter in another set of conditions. You can learn more about filters from the ASP.NET Core documentation articles, or from my MSDN article that I wrote last year on ASP.NET Core filters and how you can use them to really clean up your code and eliminate a lot of conditional logic and extra boilerplate code that tends to live inside of your MVC controllers and actions. So one of the questions that was asked on Twitter before I started this presentation was, how does Razor Pages impact performance? Is there a difference in performance between MVC versus Razor Pages? And so I ran a number of fairly unsophisticated benchmarks locally, trying simple, similar page setups between Razor Pages and MVC actions and views, and I was unable to find any difference in performance between the two. So in terms of benchmark details, I was just running these on a single, multi-core computer with an i7 CPU and a ton of RAM. I think I have 24 gig of RAM. I'm using the Apache Bench console runner, which is the simplest way to just run some load against an application. I was using Kestrel with no console logging, so Kestrel's just running there on localhost and handling all the requests that Apache can send at it. And the different scenarios that I was looking at were just display a page or a view. Just display a page that uses some tag helpers. Maybe build up some tag helpers to build a URL to a particular page or to a particular action method. Go ahead and use Entity Framework Core with an in-memory provider and display things like a list of customers on a page or on an action with a view. And in every one of these cases, there were differences from one run to the next of how much time it took, but there was never a noticeable difference between doing the same operation in Razor Pages versus in MVC. So I ran the scenarios. It's not perfectly scientific. It wasn't done in a test lab on a special computer that wasn't doing any other work. So take this with a grain of salt. But from my own personal simple benchmarks, I wasn't able to find any noticeable performance difference between Razor Pages and MVC. So what I would recommend to my clients is that they not really be concerned that Razor Pages have a negative performance impact, and that you should not make your decision of whether or not you want to use Razor Pages or MVC for performance reasons. If your pages are going to be slow, it's probably going to be because of data access or having too many scripts loading on the page or any number of other factors that aren't related to whether or not you're using the MVC paradigm or the Razor Pages approach in your ASP.NET MVC core applications. At the end of the day, Razor Pages is built on top of MVC. It's using the same view engine. It's using the same routing engine. There's not a whole lot of reason why I would expect there to be any significant difference in their performance, and my performance test pretty much bore that out to be true. So another question that I noted at the beginning of the presentation was, when should you use the onPut or onDelete handlers that are available inside of Razor Pages? So to here, Naushad asks, when, how, and where can we use them? I've managed to make them work in Fiddler, but of course, if you use the standard HTML form, it doesn't allow put or delete. And so the answer that I've come up with, and I've verified this with one of the team members that actually wrote Razor Pages, and the answer that I have is simply that you would use onPut and onDelete if you want to keep a simple API organized. So you want to have your onGet and your onPost available for the page itself, but maybe the page also needs to support operations for editing and deleting records. And rather than having different named post action methods for those, which you could also do, you would like to use JavaScript callbacks to make those, using Ajax or some similar library with jQuery or whatever you want to use to make that communication call. And when you send those calls, you want to use a put for your updates and a delete, the HTTP delete verb for your delete operations. You can do all of that and keep all that logic co-located with your get and your post behavior rather than having that in a separate API controller. So if you wanted to do it with a separate API controller, now you would have to invest in creating a controllers folder if you didn't already have one. You'd have to have this API controller that you would have to write, and it would use the standard MVC approach for building that API. And then it would probably have a different route because you'd want to make sure that your API controller probably lived in a different route than your pages did. So maybe you have a customers page that you're trying to manage customers and do, create and list and update and delete. You would end up having the listing and getting of customers and creating customers with a post all living inside your customers Razor page. But then when you wanted to update or delete a customer, you would end up with this customer's API controller somewhere that would have a different set of routes that you would call through JavaScript and would perform operations that are logically related but are now in this different folder in your application. And I think that would end up in a way that wasn't necessarily as well organized as you would like. Instead, because the team supports onPut and onDelete, you can just put those methods right on your customer's Razor page. And even though you won't be able to call those directly from a hyperlink or from a form post, your JavaScript that's on your customer's page would be able to refer to these verb-based handlers directly on that page and still get that organizational behavior. All right, so does that make sense? In speaking with the product team, there was actually some discussion about whether or not to even include the onPut and onDelete handlers because they aren't kind of the main case that Razor Pages are designed for. But they didn't see any reason to artificially, block customers from using these handlers if they found that there was a reason to do so. And the best reason that I could come up with is just to keep your simple API organized in one place. Now let's spend a few minutes looking at some demos of using Razor Pages to organize an ASP.NET Core app. All right, so in this demo, I want to show you a few different features of Razor Pages that we've gone over as part of the presentation, as well as give you a chance to kind of see the difference between a default organization MVC project and one that is built using Razor Pages. So this is actually an example I've been building for a little over a year now. It's got a couple of MSDN articles that relate to it. You can find all of the code on GitHub. The URL will be in the slide deck. The default organization for this is here, and this is using what should be familiar with controllers and view models to manage a simple application whose purpose is to kind of manage some different types of entities that maybe you're using for a game. You've maybe heard of Plants vs. Zombies. You've maybe heard about the game Pirates vs. Ninjas. And I think in Plants vs. Zombies, you can fight pirates, and there might even be ninjas in one of the new ones. I don't know. But that's kind of the idea here is you've got a Ninja's controller, a Pirate's controller, etc. And all of these have associated view models. All of these have associated views. And so in order to work with this application, as you continue to add different types of things that you want to be able to manage and edit and manipulate, you're going to see this project structure just continue to balloon and get larger and larger inside of these folders. There's not a whole lot you can do to deal with this necessarily using the default structure. Inside of controllers, you could add different folders for ninjas or pirates, but there's only one of each of those controllers, so it's not necessarily going to help you out that much. You could organize it based on API controllers versus, I don't know, CRUD controllers or something like that. But again, it just doesn't scale very well. And you still are going to end up with a bunch of different things in controllers, a bunch of different things in view models, and then a bunch of different subfolders inside of views that are needed in order to use this structure. Now, without talking about Razor Pages, you can tackle some of this issue by using the built-in feature called areas. And so in here, you could go and create a different area for each one of these different types of things, each sub-feature of your application that you wanted to work with. And that can work reasonably well. It's still inside of each area. You end up having to use those same folder structures, though. So you still have controllers and view models and views. And so it's a little bit better because now everything is pretty much inside of the area subfolder, but it's not as good as it could be. And so last year I wrote an article about feature folders or feature slices. And here I created a features folder. And inside of features, there's subfolders for each one of those different types of things. And within them, you've got all the details you need for a given entity or feature that you're working on in your application. If we look at Razor Pages, we can see that they're similar to feature folders in that there is a single root level folder here, in this case called Pages. And under Pages, you can see that we have a single folder for each one of our features, each one of our types of things that we want to deal with in our application. Now, unlike even feature folders, which still used separate files to represent things like view models and views, the nice thing about Pages is that they're very simple, and Visual Studio's tooling helps you to bind together some of those different classes so they don't take up as much space inside Solution Explorer. So if we look under ninjas, I wanted to have swords as a separate routable area of the application because these are ninja swords and not pirate swords or what have you. And so you would navigate to this from the web app by going to /ninjas/swords, and that would bring you to this index page. So this hierarchy matches the natural routing that I expect to use for the application. Likewise, the index and details pages are simply accessed from /ninja/details, and where they require a code behind, it's associated with the file using Visual Studio here so that I can expand and collapse access to this page model. Now, as we look at this particular Razor page, there's a few things I want to call out. First, in the presentation, I mentioned that you can use a route template inside of your page. You specify this as part of the app page directive. And I also mentioned that by default, if you're using named handlers, those named handlers don't have anything in the route that is set up for them. So what you're going to see when you create links to these named handlers using the default tag helpers, they're going to be applied as query strings. And so you might see something like /ninjas handler equal delete as an example of a URL that might be generated. However, if you specify the handler parameter as part of your route template, then you'll end up with having that as part of your route, which is more familiar with how you'd expect if you're using MVC style routing, where you expect to have the action, or in this case, the handler, be part of the route that you're specifying. Since this handler route template includes a question mark, that means it's optional. So I don't have to specify a handler, and I also don't have to specify an ID. When I want to use this is when I'm going to delete one of these items. I want to be able to say, /delete/1, and this will work in that scenario. Looking at the rest of this code here, you can see there are a few tag helpers They render nicely in this purple color here. So you can see I'm linking to the details page using ASP-page equal details. I'm specifying a route variable here, which is going to be the item ID, so the details will work. I have a form that I'm working with here that does deletes, and you can submit to delete an item. By default, a form will do a get request. I really want this to be a post, so let's say method equals post on this form. And likewise, we'll do the same here. Make this a method equals post. And that will ensure that they're going to hit those post handlers that I want on this page. Looking at this second form, you can see that it is specifying an ASP page handler of add. By default, if I don't specify an ASP-page tag helper, it's going to go to the same page. So these delete and add handlers are going to be found on the index.cshtml page, and they'll be located in the page model, which is index.cshtml.cs, located here, and we'll look at that in just a second. Inside this form, I'm using some other tag helpers to simply validate that the name is correct and use the annotations that I've set up on that view model to make sure that the ninja to add .name is going to be what I want it to be from a validation perspective. So now let's look at the page model. The page model in this case is just called index model. It inherits from page model, which is a built-in type that offers some helper methods. It has a couple of properties on it that include a list of ninjas, which we're going to see in a moment when I run the page, as well as this ninja to add property that I have specified with the bind property. And so the ninja to add is going to get bound anytime I'm doing a non-get request. So in this case, we're going to see when I do a post, it's going to do model binding against this ninja to add type. And that form that I just created using tag helpers is what's going to bind to this property. I've also defined a ninja view model. You don't have to do this necessarily. This is just a for example. And so this is specified as a class that's internal to the index model itself. Now, you can use your page model as a view model, which is more typically how I would do it. But I wanted to demonstrate that this is an option where you can set the view model for this page as a separate standalone type, and then just make it an internal type as part of this class. This is an inner class inside the index model class. Here I'm using a attribute, the required attribute, to make the name be required, and we'll see that come into play when we do model validation. Because Razor Pages support dependency injection, I am specifying that I don't want to just talk to the database directly inside of my page. I don't want to mix my data access and my UI concerns together. Instead, I just want to specify an interface that I'm going to use to go and get my list of ninjas or to go and add a new ninja to the system. And so that interface I'm defining as an iRepository. I'm using the same iRepository across all these different samples here so that there's some consistency. And all this does is support a list method that can go and fetch the list of ninjas. And then I'm going to map that using a .select into my ninja view model and just copy over its ID and its name so that when I view the page, I'm not viewing my data model, my entities that came straight out of the database. Instead, I've mapped those to a view model that just has the specific details that my view requires, or in this case, my page requires. I have a method here, another named handler called onGetBlowUp that just throws an exception, and I'll show you why that's there in just a moment. And then I've got these post for add and for delete. I mentioned that you could use an onDelete handler if you wanted to, but you'd have to use some JavaScript to call that because you can't have a form on a page that deletes something or uses an HTTP delete verb. And inside of my onPost add async, I'm checking model state.isValid. Otherwise, I'm going to add this new ninja. And then when I go to delete, I don't do any model validation because, as we'll see, the delete is just passing in an ID that I've built myself. So in this case, I chose not to do model validation. Another reason not to do model validation in this case is that when I do a delete, it's still going to bind this property on the delete method, but it's not going to have any value necessarily. And so I want to make sure that I don't get a spurious model validation error when really I'm just trying to delete an entity. So let's go ahead and run this page and see what it looks like. We'll load the application. we'll look at our list of ninjas. Let's go ahead and add a new ninja. We'll call him Hideo. We'll add that ninja, and let's go ahead and add another one. And you can see we're listing these now from the Razor page. If I try and add a ninja and I don't specify a name, my validation works as I expect. So I see that the name field is required. If I put in a new one that has a name, we can see it gets added as we expect. And of course, I can delete ninjas and they get removed just as I would expect too. Now let's look at that blow up named handler that I mentioned. I want to talk about how we can specify a shared error page. By default, when you create an ASP.NET Razor Pages app, it's going to drop into the root of your pages an error.cshtml and also a layout.cshtml. And you'll see both of those are missing in this particular version of Razor Pages app that I've created. And so I created a shared folder here for my shared files for my Razor Pages, and I've placed in there my layout and my error. And in order to get that to work, I had to do a couple of small things inside of Startup that I wanted to show you. And so in here in Startup, you can see I've changed the page relocation formats so that it adds /pages/shared to its list where it's going to search. Otherwise, this isn't something that it looks in. It doesn't exist. The other thing I've done is I've made it so that my /shared/error page is going to map to a route of simply error. And what that allows me to do is come down here and say use exception handler error, and that will map to that error Razor page. So let's see what that looks like. Or when we hit the error in the application, which is going to be on the /blowup handler, you'll see that right now I get a detailed exception message. And the reason for that is that by default I'm running in development. And if you noticed when I showed you here, if my environment is development, it's going to use the developer exception page. It's not going to call this exception handler. So what I want to do is switch over to using production. So we'll come over here and change to use production, run the application again, and come in here to the ninjas part of the thing and say blow up once more. And you see now I'm hitting that error page. So I get information that doesn't show my stack trace. It's a little bit better experience to give to an end user than something with all of the code from my application. You can also see, just to demonstrate that this is really using that route, I can just navigate to the /error route as well. And because of this code that I added in Startup here that changes that route, I've added /shared/error as a route, or rather I've added error as a route to the /shared/error Razor page that's located here. All right, so that shows you just a few of the different things that you can do with Razor Pages and how you can use Razor Pages to organize your code inside of a larger application and not just for something trivial. Remember that since these page model classes are full classes, they don't have any static dependencies. They don't have anything that ties them to HTTP context. They're no more untestable or spaghetti code than your controllers are today. And so you can unit test this code if you want to. You can write integration tests, which I highly recommend. Check out the docs on that I wrote. And you'll be able to have well-architected code using these Razor Pages that could be even more well-organized than the code that you have today if you're using the default model view controller structure in your projects. Let's look back at those myths that we talked about at the start of the presentation. The first one is that Razor Pages are only for code newbies or folks coming to .NET from PHP or some other scripting language who aren't ready for MVC. I think I've demonstrated that you can use Razor Pages even if you're a real .NET developer, real in air quotes, and you appreciate architecture and you know what you're doing. So I'm going to say that we've pretty well busted this myth about Razor Pages. The second myth is that Razor Pages are awful because they look like web forms and oh my gosh, they've got code behind files. I totally don't want to do this again. I think I've demonstrated that those code behind files are actually a good thing in the case of Razor Pages. They support dependency injection. They support proper separation of concerns. There's nothing in them that's intrinsically bad from an architectural standpoint or that would prevent you from writing clean code. So aside from the fact that they might share the term code behind that we associate with a web forms technology, there's nothing architecturally impure, if you will, about Razor Pages. So I think we've pretty well busted this myth as well. And that goes on to the third myth, which I think is somewhat related, which someone said, you should only use Razor Pages if you don't value code quality. You're okay with just having a mess of spaghetti code. There's nothing about Razor Pages that says, hey, why don't you just take all of your logic and your business logic and your validation logic and your data access, mix that all up with your HTML and just create a big mess inside your view, or in this case, your page. Razor Pages don't have to be built like that. I don't recommend that you build them like that. You could build your views in MVC like that if you really wanted to, but you don't. And so I suggest that you don't do that with your Razor Pages either. Okay, so I am just about out of time here. I do want to let you know that you can get some of the examples that I showed here from my GitHub sample on organizing ASP.NET Core. This is actually the sample that's associated with my MSDN article on Razor Pages from this month. You can also go and learn more about ASP.NET Core and Razor Pages from ASP.NET Core Quickstart.com. And if you use the code .NETConf17, you'll get us 20% discount on this course. And finally, if you have any questions, please feel free to reach out to me on Twitter or through my website at ardalis.com. And if you're interested in following my podcast, you can sign up for weeklydevtips.com to get a weekly, simple, pragmatic tip on how to become a better developer every week. Thanks a lot. I'll see you next time. Bye.